close out the fitting tasks, I'll show an example of how to do a radial profile fitting. So here we have ABEL 2390. You can see lots of diffuse emission and a lot of point sources. I actually want to get rid of the point sources from the fit. The easiest way is just to exclude them, and really the easiest way is just to go ahead and run one of the detect tasks. So I'm going to go ahead and run just cell detect. I'm not going to worry about an exposure map or PSF map. I'll use a fixed cell size, let's say of 9. And you see it does a pretty good job of detecting all the point sources. There's a little bit of stuff here that I want to keep. So I'm going to select those, so shift drag selects them, and then just the delete key deletes them, or you can do it all through the menus. Now the thing is, I want all these regions to be excluded. So I can select them all and now change their properties. So I can change all the properties at once. So properties excluded. And you can now see that they all have the little red line that goes through them, so they're all now to be excluded. My next step that I would normally do would be to draw the ellipse or the annulus that I want to use to create the radial profile, but there's a Chow-ism that the excluded shapes have to be excluded from something. So they have to come last in the list of region shapes. Long discussion. The easiest way to do this is I'm just going to go ahead and select all the regions. So I'm going to Control A, which is the keyboard shortcut, to select all the regions. And I'm now going to cut them away from DS9 into the region buffer. So this is just like cut and paste of text. So cut them away. They'll come back in a little bit. I'm now going to draw our annuli for our radial profile. I'm going to use an elliptical annuli just because we can. So kind of get a rough idea. Something like this. Select it, shift, and then rotate. Kind of rotate it into position. Resize a little bit more. I can now double click it. I'm going to make the inner radius 0, 15 radii, generate, apply. Okay, so that looks okay. Let me just use the arrow keys here to recenter this guy a little bit. That looks better. So now the center's kind of there. So now that I've got the annuli drawn, I can bring back the excluded regions. So just edit and paste the regions. And now if I list the regions, we can see the ellipse with all the radii, so that's the radial profile, and then all these ellipses are going to be excluded from it. They don't all intersect it, so they don't all matter, but the ones that are in here will get excluded. I can now then go and do the Sherpa radial profile fit. It's going to ask me what units do I want. Do I want physical units or arc seconds? I'll leave it in physical. Which 1D model do I want to use? I'm going to use a Gaussian. It's not a great, it won't be a great fit, but it's okay. Model number 2, we'll add a constant because I haven't done any background subtraction, so there might be a constant DC level that I need to take care of, and we'll leave the fit method alone. So it's gone off and extracted the radial profile, gotten now into Sherpa, and we're kind of here at this place. I know the position of the, because I'm doing a radial profile, and if this really is a Gaussian, then the position should be 0. So I'm going to freeze that. The amplitude of this thing should be close to, well, it's going to be the integrated value, so it's going to be higher. Fourth half max, you know, that's probably okay. Constant of 1, that's pretty high, so let's just do 0.1. And now if I plot this, so what I see here is surface brightness and the delta chi-squared, so obviously those are way off, so I can change the amplitude to something like 20 watt. Fourth half max is going to be, you know, half. Let's just say 50. Oops. Return plot. Okay, that's not too bad. We'll go ahead and let that fit. So it comes up with, and then we can plot the fit. So these are the best fit parameters: the fourth half max, the amplitude, the constant. You know, it's obviously not a good fit. You know, a beta profile or something might be a better fit than a Gaussian here. But you can kind of see that's how it works. I can then exit, and it will redo the plot again, and it will give me the location to restore the save session. So if I now conda sherpa, copy, paste, and then I can do plot fit. Don't worry about that. And you get the expected plot.